your fundamental mathematics. So from the 10+2 onwards, we are studying the mathematics. So in the last semester, or also we are studied the mathematics. So in the mathematics, we are studied the fundamentals of first order ordinary differential equations, second order ordinary differential equations, time domain analysis, Laplace transform analysis. All these studies you studied in the previous semesters. And also you studied the basic electrical engineering. It is a basic topics of all KVL, KCL, what are the elements involved in the electrical networks, all you are studied. So now we are going for the network topology, magnetic circuits. Then we are going for the transient behavior of the system, steady state behavior of the system, and two-port networks. So the course objectives will concern with respect to first unit is you are concentrated on the network topology. If the size of the network is increases, so how to go for network analysis using network topology. So that is the one part. And another part is if it is a coupled circuits, for this coupled circuits, how the inductively coupled circuits are converted into conductively coupled circuits by using dot conversion. We are going for the analysis of the electrical networks. So that is the course objective. In the outcome also, we are getting the knowledge on the network topology as well as magnetic theory. Then coming to the second objective, the behavior of the electrical elements RLC, we are studying with respect to different excitations, DC excitation, AC excitation, and there are so many periodic functions are there. So if you are giving connection to the any RL, RC, RLC circuits, so you are analyzing the time responses. So that is the study you are going in case of the second unit, and we are getting the knowledge and analyzation of the different behaviors if you are giving for different excitations of a particular circuit you are studying. Then coming to the third unit, so two terminal networks we are considering. So in case of a two terminal networks, there are different parameters are there. So Z parameters, Y parameters, ABCD parameters, inverse ABCD parameters, G parameters, hybrid parameters. So and the correlationship between the parameters, so that is Z to Y, Y to Z, like that different relationship between the parameters we are studying. And we are also studying the image parameters, and we are also designing for the characteristic impedance and attenuation constants, like that the study will be there in the third unit. So in that you are getting the knowledge as an outcome. Whenever a two pair of terminals are connected to a rectangular hollow box, so how we are going for the calculation of the parameters. So if the load is connected at one port, the image parameters, how you are calculating, all these analysis part you are studying in this third unit. So while coming to the textbooks, so I am recommending the Van Valkenburg, Roy Chowdhury, Keith, and Joseph Administer. So these are the four books I am recommending for your study. And the open source link are also given, NPTEL videos. So by using that also you can learn, you can get the knowledge in this subject. So coming to the network topology of your first unit, so it is categorized with the subtopics. So necessity of the network topology, some important definitions and terminologies we are studying. So how to construct a complete incident matrix and what is a reduced incident matrix we are studying. Then basic cut set schedule and basic tie set schedule we are studying for a planar networks or planar graphs. So it is a graph theory. So graph theory is common for every engineering subject. So in case of computer science is also you are studying graph theory. In case of mechanical engineering also you are studying graph theory. In case of physics also you are studying graph theory. So like your electrical networks, you are studying the graph theory in terms of network topology. So all are almost similar way only. The graph theory is almost similar way only. So now come to the introduction part of the network analysis with respect to network topology. So network topology for any electrical network can be easily taken the structure of the network. So you are not concentrated on the current flowing through the particular branch and what are the passive elements you are taking and what is the sources you are taking. You are not bothered about all these things. You are just taking the structure of the electrical network. With respect to the structure of the electrical network, you are writing the Kirchhoff's current law equations, Kirchhoff's voltage law equations. So that is the most advantage and very added flavor of this network topology. So very complexity of the networks are also reduced in a very simple way, and while you are going for the programming, the computational time is also very less to get the solution of the problem. So that is the most advantage of network topology. So this network topology we are using more in the power system networks. So because there are different types of transmission lines are there. Short transmission lines, long transmission lines, medium transmission lines are there. So many elements are interconnected to form as a complex network. So at that time, if you want to go for calculation of a particular responses, then you can go for the structure of the network for finding the values of those responses by using this graph theory or a network topology. Now, the topology is concerned. Finally, either if you go for the tie set schedule or you can go for the cut set schedule, you can get the KVL equations and KCL equations only. So, but the time which is involved in writing the KVL or KCL equations as compared with the topology, it must be very less. So that is the most advantage. And coming to the topology of the electrical networks, so once again I am recalling, we are taking only the structure of the elements. You are not concentrated on those voltages, currents and any passive elements. So every element is replaced by a straight line with ended terminals. Okay. So the important definitions of the network topology. So what is a network? So network is a combination with respect to connection of elements. So what is a circuit? So circuit is a closed path. So circuit is a closed path. So there is no open path, then you can call it as a circuit. So if it is a open path, then you can call it as a network. So the difference between circuit and network is network may or may not be a closed path, but circuit must be a closed path. Then what is a branch? So any element having end terminals, you can call it as a branch. So a resistor, a inductor, a capacitor, a voltage source, a current source. So these can be having ended terminals. Okay. Then what is a node? Node means two branches, three branches, or n branches are connected at single point. You can call it as a node or a vertex or a vertices. And what is a graph? A graph is a particular network. You are replacing the entire network with a structure as a straight lines and nodes ended nodes. So all nodes and all branches are connected, then you can call it as a graph. So what is a graph? For that graph, I am taking one example. So here, this is your circuit. So for this circuit, we are having some passive elements. So I am nomenclaturing the branches 1, 2, 3, 4, 5, 6, 7. So 7 branches are there. So for 7 branches, every branch must be having end terminal. So inductor is connected to the resistor. So node A is formed. So similarly, two inductors are connected, node F is formed. So like that, so every branch having a terminal, two terminals are meeting at a point, then you can call it as a node. So like that, for your given circuit, so this is the graph you are getting. So what is a subgraph? So it is a subset of a graph, or you can call it as a connected graph. So subgraph means it is a subset of a graph, or it is a connected graph. So the above figure is a full graph of a given circuit. So while we are coming to the subgraph, I have taken only 4 branches, 3, 5, 6, and I have not taken the 1, 2, 4 branches. So still the graph is pending, then you can call it as a subgraph. Next, coming to the connected graph. So what is a connected graph? The entire network is replaced by a structure, then you can call it as a connected graph. So this is a example of a connected graph. So here 3 nodes are there, 4 branches are there. So node 1, node 2, node 3 are the 3 nodes. Branch 1, branch 2, branch 3, and branch 4 are the 4 branches. So such type of structure you can say that a graph. Then what is a unconnected graph? So to understand the unconnected graph, so we have to go for a simple example of a transformer. So transformer is not electrically not coupled with each other in a electrical form. So here 2 windings are there. Between the 2 windings there is a magnetic field. So with respect to the primary winding, you are getting some voltage in the secondary winding. But while you are drawing the graph, so this first one you are considering as like this. So 3 branches are there. Voltage source and capacitor will form as a branch 1. Resistor will form as a branch 2. And the inductor will form as a branch 3. And the second point of RHS, so a inductor and a resistor are there. So the branch 4 and 5 are there. But there is no connection between these two. There is no connection between these two. So such type of graphs are called unconnected graphs. Next, coming to the path. What is a path? So path is the connection between the nodes. So if you take an example, 2 nodes are there, node 1 and node 2. So if there is a connection between node 1 and node 2 with a branch, then you can say that it is a path. So the path is moves from branch 1 to branch 2. So similarly, another example, so two nodes are there, branch 2 and branch 3. So sorry, node 2 and node 3. So if a branch is connected between the two nodes, so it is a path moving from node 2 to node 3. So that is the example of a path. And then what is a closed path? So closed path means the current flowing through the circuit must be same. The current flowing through the circuit must be same. So if you take here, so it is a closed path. So the current is flowing around the circular direction in a particular loop. In a particular loop. So those are called closed paths. So if any one branch is open circuited, then it is a open circuit. Open circuit. Next, coming to the planar and non-planar graphs. So what is a planar? So planar graphs means there is no touching of the elements. There is no touching of the elements. Then you can say that it is a planar graph. So here see these 5 nodes are there. So individual elements are connected at the nodes only, but the branches are not touching. The branches are not touching. But while we are coming to the another example, here the two branches are touching. So then you can say that it is a non-planar graph. So for the network topology, we have to concentrate on only planar graphs only. So we are not considered for the non-planar graphs. So coming to the oriented graph. So what is a oriented graph? So oriented graph or a direct graph means for a particular graph, if you are giving some directions. So here you are giving some directions. So those directions you are giving to a particular graph, then you can call it as a direct graph or a oriented graph. Then what is a tree? So tree means it is a subgraph. It is a subgraph and it must be a open path. And it must be a open path. So for a particular graph, you can draw some combination of trees. Some combination of trees. So here I have taken one combination for the given graph. So branch 1, branch 4 and branch 6 are the tree branches. So branch 2, branch 3 and branch 5 are the links. So links is a open path and twigs means a tree branches. Twigs means a tree branches and links means a open path. Links also called as a cards. We are also called as a cards and the tree must be a subgraph. The tree must be a subgraph or a connected graph. So coming to the code tree. So what is a code tree? Code tree is the complement of a tree. So if you are considering 1, 4, 6 are the twigs and 2, 3, 5 are the links. The code tree is 1, 4, 6 are the links and remaining are trees. So then you can say that it is a code tree for the given tree. For the given tree. Next, coming to the properties of a tree. So the nodes are denoted by capital N. So the tree must carries with all nodes. The tree must be carries with all nodes and the branches never be same as the given graph. So it must be always less than the given graph only. So it will be in such a way that to form as a subgraph. to form as a subgraph. And the tree branches must be also named as a twigs, and these must be considered as n minus 1. So for example, for a given tree, n nodes are there. So the twigs value must be n minus 1. So 3 nodes are there, 3 minus 1, only 2 twigs will be there, and remaining all in that particular graph must be a links. Must be a links. And the tree must be always a open path. There is no closed paths. And coming to the standard formula for calculation of the link, so link is represented by L. So L is equal to B minus N plus 1, where B is the number of branches, N is the number of nodes. Okay, and the degree of the node must be considered as number of branches attached to the node or attached to the node. So the degree of the node of a particular tree can be considered as the number of branches attached to the node. Okay, so now coming to the construction of a graph. So I already told the graph carries with only straight lines, So every passive element and active element is replaced by a straight line with a terminals, So these straight lines are line segments, or you can call it as a branches. So these branches are connected at particular node. Then you can say that it is a vertex or a simply node. So these branches and nodes are forming as a graph. So the graph can be considered with respect to number of branches and number of nodes. So you can nomenclature the nodes are A, B, C, D. Either it may be a capital letters or it may be a small letters, or sometimes you can use the numerical numbers also. So similarly, the branches are also nomenclatured as numbers 1, 2, 3, 4, 5 branches, or A, B, C, D branches, and etc. Now, while going for the branch of a graph, so if a voltage source with internal resistance is there, or a current source with parallel resistance is there, so replace with a straight lines. Okay. So now coming to the symbolic representations of the elements in the graphical theory. So voltage source is short circuited. So between the terminals, so resistance, inductance, and capacitance you are drawing as a straight lines with the ended terminals. So current source must be open circuited. So this is open circuited. Voltage source is short circuited. So this is the concept you have to always remember while you are drawing a graph in a network topology. Now coming to the example, so the given network, so for this given network you are drawing a graph. So here how many elements are there? 7 elements are there. First you have to go for nomenclaturing the branch elements. So 1, 2, 3, 4, 5, 6 and so on. So if 7 elements are there, then you can get 7 branches. And how many nodes are there? Node A, node B, node C, node D, node E, node F. So we are having 6 nodes. So I am nomenclaturing A, B, C, D, E, F. Okay. So this is a graph for a particular network. Next, what is a oriented graph? So to understand the oriented graph, so here I have taken a electrical network. So for this network, so the first branch is a voltage source with internal resistance. So E is replaced by a straight line. Then R1 resistor is replaced by a straight line. then R3 resistor is replaced by a straight line. Then a inductor is replaced by a straight line. A capacitor is replaced by a straight line. So a voltage source in series with the resistor is replaced by a straight line. So current source is open circuited. So that's why how many branches we are getting? 1, 2, 3, 4 branches. 4, 5, 6 branches you are getting. 6 branches you are getting. So first branch is R1 resistor with a voltage source. Branch 4 is R2 resistor. So branch 2 is inductor L1. So branch 3 is capacitor C1. So branch 5 is resistor R3. Branch 6 is your second voltage source with a resistance of R4. So here the current source is open circuited. So you never take any branch in the connection between the points C and D. So now this is a graph. So for this graph, if you give your own directions, then you can call it as a oriented graph. So here the direction of current moving like this. So here the direction of current moving like this. 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 So branch 6, the direction of current moving like this. So I have chosen some direction. We are not bothered about the total circuit. So we are concentrated on the structure of the given graph. So for this graph, I have chosen different directions. So then you can say that this graph is a directed graph or a oriented graph. Next, coming to the most important thing is 3 matrices. So one is a incident matrix, So another one is a basic cut set matrix, and the last one is a basic tie set matrix. So incident matrix is denoted by A, or you can call it as reduced incident matrix, and the complete incident matrix can be represented by A cap. So it gives the relationship between the number of nodes and number of branches of a given graph. So the complete incident matrix will give the relationship between number of nodes and number of branches. Are you understanding? So the column is a nodes, the row is a branches. So you have to map the nodes and branches, then you can get a complete incident matrix. So to understand the incident matrix, so we have to go for values 0, +1 and -1. So if Aij is equal to 0, so the branch J does not incident on node I. So that means the incident of simply a current is not incidenting on a particular node, then you can say that the value of incident is 0. So if Aij is equal to +1, the branch J is leaving away from the ith node, so it is not incidenting, then you can take the value of A must be +1. So then Aij is equal to -1. So if the branch J is traveling towards the node I, so that means the branch is incidenting on node I, then you can say that value of A is a -1. So like that, we have to correlate the relationship between node and branches. Okay. So the properties of incident matrix, generally you can go for it is non-zero elements only. So there must be two non-zero elements in a particular incident matrix. Remaining all columns must be zeros. Remaining all columns must be zeros. For example, 10 columns are there, 2 columns must be non-zero. So one must be plus 1, another must be minus 1, and remaining all columns must be 0. Then you can say this is one of the property of the matrix A cap. Okay. So next, the columns, if you go for the summation, of the columns, so the net value must be 0. So similar, previously I told, so 10 are there, 2 must be plus 1 and minus 1, remaining all must be 0. So plus 1 minus 1, what is the value? 0 only. So if you add the total column, then total column value must be 0. So that is the one more property of the incident matrix. Okay. So then the non-zero elements and all other zero elements must be formed in every column with respect to the relationship of node versus branches. Okay. So the determinant of the incident matrix for a particular closed loop must be 0. So these are the properties of the incident matrix. So what is a reduced incident matrix or simply a incident matrix? So reduced incident matrix or a simple incident matrix is one of the row of your complete incident matrix is eliminated. Then you can say that it is a reduced incident matrix. So the complete incident matrix is number of nodes versus branches. The reduced incident matrix is n minus 1 versus branches. N minus 1 versus branches. So to understand this, so I am going for the simple example. So the graph is shown in the figure. So this is your graph. So here 5 branches are there. So 4 nodes are there. A, B, C, D are the nodes, and branches are 1, 2, 3, 4, 5. Okay. So now we are going for the complete incident matrix A cap. Complete incident matrix A cap. Okay. So coming to the node A. So this is your node A. So for this node A, the branch 1 direction of orientation is leaving away from the node. So it is a plus sign. Then coming to the branch 5, so the branch 5 is also leaving away from the node. So it is not incidenting. So it is also plus 1. And there is no branches are connected to node A. So simply put 0. There is no incident with respect to the branches 2, 3, 4 for a node A. So similarly, while you are coming to the branch B, so the branch B carries with node B carries with 3 branches. So branch 1, branch 4, branch 2. So branch 1 is incidenting the node B. So that means minus 1. So branch 4 is not incidenting. So it is leaving from the node. So node 4 is positive. Branch 2 is leaving away from the node B. So it is also plus 1. So remaining other 2 branches are not incidenting, put zeros. Then coming to the node C. So node C, you are having only 2 branches, branch 2 and branch 3. So branch 1 is 0, branch 4 is 0, branch 5 is 0. So branch 2 is incidenting, so -1, and branch 3 is leaving, +1. Coming to the node D. So node D, 3 branches are there, 3, 4, 5. So node 1 and no branch 1 and branch 2 are not incidenting, blindly put 0. So coming to the branch 3 is incidenting, -1. Branch 4 is also incidenting, -1. Branch 5 is also incidenting, -1. So this is your complete incident matrix. So for the given complete incident matrix, so if you want to go for the reduced incident matrix, the main condition is for a particular column. So if you go for the addition or algebraic sum, so it should be 0. It should be 0. So that is the property of the incident matrix. So if you see this, so here +1, -1, 0, 0, the overall value is 0. So if you go for the second column, 0, +1, -1, 0. So overall value is 0. So if you go for the fourth column, 0, +1, 0, -1, the overall value is 0. Are you understanding? So this is the property of the incident matrix. So in a closed path must be 0. In a closed path must be 0. While we are going for the reduced incident matrix, one of the row must be eliminated. One of the row must be eliminated, and the condition is the sum of the column must be 0 only. The sum of the column must be 0. So if you go for this, so +1, -1 with 0. So 0, +1, -1, it is also 0. So if you go for 0, 0, +1, the overall value you can get it as -1. So it is here also you are getting same. So if you go for 0, +1, 0, so the D column again you are getting as -1. So if you go for the fifth one, +1, 0, 0, the last value you are getting as algebraic sum of the column. So +1, +0, +0, you can get -1. Okay. So like that you have to eliminate one of the row, then that incident matrix you can call it as simply incident matrix or reduced incident matrix. Reduced incident matrix. So this is also another example. So column C is eliminated. Column C is eliminated. Choose that the column must be either 0 or +1 or -1. So this is the condition. The column, by taking the algebraic sum, it is a 0 or a +1 or a -1. So like that you have to consider. Okay. So coming to the another example of incident matrix. So the given graph is oriented with respect to 6 branches and 5 nodes. 5 nodes. So node 1, node 2, node 3, node 4, node 5, branches 1, 2, 3, 4, 5, 6. So now we are correlating Aij is equal to 0, Aij is equal to +1, Aij is equal to -1. So Aij is equal to 0. So that means there is no connection of that node incidenting of a particular branch. Then Aij is equal to +1. That particular branch is leaving away from the node. Then Aij is equal to -1. Then the branch is incidenting on that particular node. So now come to the node 1. So node 1 we are having only 2 elements. So branch 1 and branch 2. So remaining all are zeros. Remaining all are zeros. So here branch 1 and branch 2, the incident is moving away from the node. So +1, +1, +1. Next, coming to the node 2, 3 branches are there. So branch 2, branch 3, branch 4. So branch 1, branch 5, branch 6 are zeros. Now branch 2 is entering, so it is incidenting -1. So branch 4 and branch 3 are leaving +1. Then coming to node 3, only two branches are there, branch 4 and branch 6. So 1, 2, 3 branches and 5 branch are blindly 0. So now branch 4 is incidenting, so -1. Branch 6 is leaving +1. Similarly, go for the node 4. So node 4, 3 branches are there. Branch 1, branch 3, branch 5. So remaining all branches are zeros. So that is branch 2 and branch 4. Branch 4. So 1 is incidenting, 3 is incidenting, 5 is leaving. So 1 is negative, 3 is negative, 5 is positive. 5 is positive. So similarly, coming to the branch 5. So branch 5 only, node 5, we are having only two branches, branch 5 and branch 6. So remaining all are zeros. So 1 to 4 are zeros. So 5 is incidenting -1, 6 is also incidenting -1. So once you are represented the complete incident matrix, so you can eliminate one row, one total row, such that the algebraic sum of the columns must be either 0, +1 or -1. So like that you can eliminate the node 5. So then that matrix is n-1 versus branches, and this is, you can say that, reduced incident matrix. So are you understand, students? So how you are going for the reduced incident matrix, and what are the different important definitions, so such as node, branch, path, link, then graph, subgraph, connected graph, not connected graph, oriented graph, and what is a incident matrix, and what is a reduced incident matrix, what is a tree, what is a co-tree, and all these are the concepts related with respect to graph theory. Are you understanding? Thank you, one and all.